appreciate. Good morning, good morning, good morning. It's Max. It's Max versus Button, and I will not give in. Let's go. Good morning, good morning. We got to get our tweet out. We got to let the people know what we're doing. Come on, let's go there. All right, people, come on. Come on now. Let's pull up the to-do list here. Let's get smart. Let's get educated about it. I gotta get the coffee going in my veins. All right, let's get the status update first. Okay. Oh, ho, ho, ho. Ho, 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 ho. Oh. 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 It just makes you want to press it. Look at it. Look at it. Makes you want to press this bad boy, doesn't it? Jesus. Oh. Wow. So the issue we have right now, okay, and then this is priority numero uno on our to-do list here, is that we need to make the actual green button part a tiny bit smaller there. Christian, thank you so much, brother. That means the absolute world to me. Yes! So the button, we have to make a tiny bit smaller because it is, if you don't hit it top dead center, it will hit the base. The keycap will hit the base. Okay, which we obviously don't want happening. We want a really nice, clean key press. That way, there's no weird sounds of the 3D print hitting the outside of it. All right, people. Let's get it going. Let's get it rolling. For people just joining, here's where we're at with the button. All right, I think it's looking unbelievable. It's the most clickable thing I've ever seen. Like when you see it on the desk, you instantly just want to click it. So yeah. All right, to-do list is make keycap tiny bit smaller, 0.5 millimeter. Keycap smaller, 0.5 millimeter, and then we have to. It's not going to be easy. We have to draw a schematic for PCB. It's going to be a little tough. We can do it. We can do it. All right, let's get this keycap smaller. Morpheus is here. Yes, baby. Good morning. Morpheus, how are you doing today? Are we waking up from the Matrix? Wake up, Neo. Here's our new key stems. Revolutionary design. Sad. Yes, you are blessed, sir. Yes, you are. We're all blessed to be doing it. I think you should add text commit. I think I should too. I think I gotta add your name to it, right? I gotta add your name, and I gotta say push it. I think that's a great idea. Good morning. How you doing today? All right, so come on now. A little bit bigger. Oh, I'm so shot today. Go, Max, go. Wait, Florin, real quick. I gotta give you the. I gotta show you what's up with this. I gotta show you this real quick, Florin. Oh, look at it. Look at this bad boy go. Yes. Yes. It's pretty good. It's pretty good, right? That's the big ass green button. Yes, it is. Makoto, thank you. Good morning. Good morning. All right, I gotta keep going. Yeah. So we're gonna add LEDs to it, so it will glow. The inside of the button is gonna be filled with LEDs. We're gonna make a custom PCB, and it'll have backlight, and it's gonna look sick. Right now we are making the oh my god, I just made the button bigger too. I'm so shot today. Damn it. Okay. Okay. We're making the button a little bit smaller. It's a tiny bit too big in the closure. No. Alright, that's gonna be perfect. Can't wait for it. Super cool. Custom purple version. Yes, we need the purple version. Of course, of course, of course. Go with the desktop. Look at how big this little project has gotten, by the way. Please, someone tell me I'm insane. Thank you, thank you. Good morning. Have a great day today. You're a legend. Your desktop will be there soon. I'll share the tracking with you. Jesus Christ. Okay. Version 11 of the keycap. Wow. I have to volunteer with the marketing. Face red smiling to face red smiling live. I have to volunteer with the marketing. All right, volunteer with marketing. Let's get involved. Come on. Do you have about 8,000 followers on TikTok? Because that's what we need right now. Meet again. Have you arrived at a name yet, or will it be a surprise? I have the file name as Click It, but I don't like it. I have not come up with the name yet. What's your favorite of the names so far? Happy New Year. Happy New Year, Jacob. How you doing today? Good morning. What's your resolution? Everyone in here, what's your New Year's resolution right now? Come on. I got to hear it. You are with me. I need to put some I wish you best of luck. Inspiring to see you build the physical products. Thank you so much. I think nobody does it because they're smart. Because they're not insane. It'll make you go crazy designing physical stuff. I guess there's twice as many bugs, right? You have software bugs and hardware bugs now. You can just name things. Go into debt if you have to. You can just name things. What if we have multiple names for it? If I just throw together a couple websites? Is it really that painful to build it? Damn. Did you see my file list? Hold on, I'll show you how painful it is. I will show you right now how painful it is. This is how painful it is, brother. Remember, these are all designs, all right? These are all designs. And then not only did I design them, but I printed them and they didn't work. And then I redesigned it. And then I printed it. And then it didn't work. All right, and we're just talking about a button. Just a button here, guys. Okay? We're not talking about catching a rocket with chopsticks. This is a button. But I love it. I love it. A lot of iterations, yes. All right, New Year resolution, ship my very first product, ship fast. Yes. Let's get a button on your desk. And I want to see you 2025 when the project's all done. Slam the button. Send it into production. Make your first sale. Get some MRR going. Big money. All right. So this is the scariest part of the whole ordeal here. This is a schematic editor, right? This is where we're going to draw up. This is where we're going to draw up the schematic for the PCB, you know, which is really, really something. No. I think we start with our pins. And we grab some, how many pins are there in our microcontroller? I build iOS apps. I guess the button won't work with pushing to App Store Connect, right? Absolutely, it'll work with it. So I'm putting a microcontroller in it, and you're gonna have a small dashboard similar to how Desktop has a dashboard to set up. So we can actually, the button will connect to Wi-Fi. And it'll be able to receive software updates, but we'll actually be able to tell the button whatever we want it to do. I mean, you could hook it up to Philips Hue and have it turn your lights on and off if you want to. Whatever you can think of doing to your computer, you're going to be able to have the button do. How many pins does this have? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got 9 pins. So we need a 1 by 9. We need 2 of them because there's 2 rows of pins. Come on. Okay, it sounds cool to be able to implement on top of the button to create something my own. Absolutely. And that's how I build all of my stuff. Like Desktop has the API feature so that you can grab whatever you want on the Desktop, you know? I like building hardware that you have full control over and you're not locked into the matrix. I don't know. All right, what we need to know is we gotta get ChatGPT involved here because we need to know, and I'm all out of credits on O1, the good ChatGPT. That's not good. Extensibility is a great quality. Yes, it is. Yes, it is. I think the indie hacking community appreciates that because we're all builders and we don't want to buy something that we can't mess with. Okay. God, that sucks. Why do we have to make everything? That's just how it goes. You look like Tony Stark / Elon Musk designing those electric stuff. So much cooler to design UX coding. Jacob, that makes my whole day. All right, I'm gonna go to work today and think about that comment all day. Let's grab a screenshot. I'm grabbing a screenshot of that right there. You're incredible. Comment of 2024 on the last day. God, the non-paid ChatGPT is not good. It messes me up more times than it helps. Also, they make this software difficult on purpose. I don't know why, but they do. They think it's awesome. They think it's funny. All right, so we are going from GPIO port 4 to ground. And the hilarious thing about GPIO port 4 is it's on pin number 7. One day when I start designing real stuff, not that a button isn't real stuff, I'm just going to make shit that makes sense. Why are we putting on a microprocessor pin 4, GPIO 4 on, right? What the fuck? All right, so what we did right there is we just made our, that's our microprocessor. This right here, this header. And then this is going to be our actual button itself, right? And so 7 will be pulled high with a pull-up resistor in software. So you can do that. You can do that all in software. You pull 7 high, and then it is connected to ground via the 2, which 2 is ground here. And then when you hit the button 7, the pull-up resistor will read low, because instead of being stuck as high, it'll switch to being connected to ground, which will make it read low, because it's going to make the connection to ground, right? Instead of just there being the signal going back to the microprocessor as reading high. And that's your, what a time to be alive. Yes. And that's your basic explanation of that. All right. And so the switch is actually really easy. We need to figure out our LED design, and I think that we should go with the W12S. I forgot what it is. Like WB12. What exactly the microprocessor does in this case? So the microprocessor holds the code, and it's the brains of the operation. So when I hit the switch button, it'll recognize that the button's been switched, and then in this case, I have it set up to emulate a keyboard right now, and so it's like a smart keyboard in that it can do whatever. Like I could have it send, send A keystroke, wait 500 milliseconds, send B keystroke, wait 500 milliseconds, send shift, don't release shift, send C, B, L, release shift. Like you can do whatever you want with it. And that's how we're going to get it to open the terminal, go to our project directory, and make the git commits, and also input a message with the commit. The microprocessor is critical, you know. $50-50. So that's a 5mm by 5mm surface mount device package, which means we're going to throw that bad boy right on top of a PCB, and with the pick and place machine, and then we'll throw it on a hot plate and it'll solder itself, just like the microprocessor. So we have to throw some of these LEDs into our design. The thing we're going to need for our LEDs is we're going to need a resistor at the beginning. Oh, thumbs up. We're going to need a resistor at the beginning of the circuit. Maybe. We're going to need a large capacitor, definitely, at the beginning of the circuit, so that when we have it change colors or change brightness or whatever, it doesn't get messed up. And then we're going to have a tiny capacitor right in front of every LEDs. And I almost like to think of those as just like a little tiny battery backup for them, where if something changes or they peak or whatever, they need a little bit more power draw, you don't see any flicker because they have that capacitor saving the energy for them right there, and it can just boom, here you go. So let's throw some of these LEDs in there. Some 50/50s. These are going to be bright too. We got to make sure that we get the right ones here. That's going to be critical. Those are 2020s. These are 2020s. We don't want those. We're going to use the big 50/50s. These ones are awesome. All right. So 5x5. We're going to hit this, and then we're going to hit place repeated copies. And then how many 5x5 are we going to have on this thing, on this unit? So I'm thinking, yeah, Jacob, you should try to build something. It's good for you. All right. I'm thinking that we try to throw in, because these are only 5x5. Okay, they're not that big. Like this whole case is 60x60. Okay, so I'm thinking we place, and the more LEDs we have, the better it'll be for diffusion. So you won't see like a strong LED in one area and not the next. So I'm thinking we throw 1, 2, 3, 4 in the top, and then we try to do 3 in the bottom there. Oh, we can't do 3 in the bottom because the microprocessor is going to be right there. So we do 4 in the top, and then we do 2 in the bottom. We have 6 in total. That's going to be great because we'll have plenty of headroom for power there. Let's go. Let's go. So when we lay it out in the schematic, the positioning doesn't matter. Oops, I'm on my face by accident. When we lay it out in the schematic, the positioning does not matter. All right. We do need to ask ChatGPT here what a good, because I don't remember, what should we use for a cap in front of each LED, and what should we use for one on the entire circuit? Come on. Okay, filter. No, we know what they're for. All right. Yes. A point UF ceramic. Come on now. So the really nice thing about a ceramic cap, not an electrolytic cap, a ceramic cap, is that with the ceramic cap, they are there's no polarity. So for someone like myself, who has no idea what they're doing, it's hard to mess them up, right? Oh, 402, baby. This is the bad boy we need right here. Yes. Do you already have the LEDs at home? The LEDs are on the way. They're coming from China right now. I think that I have 1,000 of them coming, and they're gonna come on a big reel, like a huge tape that'll get put into my pick and place machine. All right, 40/20. Let's grab these. Come on, we gotta keep going. Oh, this is an 0402. We want the surface mount version. This was really hard for me to wrap my head around, but the capacitors are going to bridge ground and VCC, so it's going to bridge 5 volts and ground right before the LED. We need a resistor for data. This is going to turn into a mess very quickly. I think that this 1,000 farad capacitor or whatever it is going to be a 1210 size. But I will fix it if it's not. I just want to get going with this because it's already 611. Okay, so let's do data first, and then we'll do voltage and ground. So I'm gonna grab a chip here. As well, do you already? Yeah, as well the microprocessors. Yeah, I have like only 100 of the microprocessors at home though, because those are a little bit more expensive. Those also come from China. All right, so this is data. It's going to go in. It's going to come out of the GPIO port 3, and then go into this resistor right here. This 330 ohm resistor, and then it's going to go into data in, and then out data out. Pretty simple setup. Remember, all we're doing is drawing the schematic. This is nothing positional. So this is like writing the back end code without without having any front end code. And all I did right there was just told the schematic that ends right there. Data in, data out. Okay. And then we have to supply the power, which power is going to be on 5 volts is right here. Oops, that's not what I want. I don't think we need one. Okay. We do not need one. God, if I do that one more time. Okay. All right, so we're going out of 5 volts right here. This is probably, unfortunately, going to be an electrolytic capacitor. So we are going to need... What's the title of the soundtrack? The soundtrack is White Bat. White Bat Vibrant 80s Synthwave playlist. Gets me absolutely fired up out of my mind. Okay. So we have to hit one leg of the capacitor before going in to voltage in. I mean, it's simple stuff, but it's also not at all. If that makes sense. It's simple stuff, but it's also very infuriating, and I have no... It's just stuff that I researched. we have another ground? We really don't. Okay. I like this better. I think that's cleaner to look at for the schematic. For it to dip down like that and then pop back up so you can see that we're hitting this capacitor. This is just a little tiny guy too, a little tiny capacitor. And these actually like matter. You want them as close as possible to the LED. Like you want it snugged right up there so that you get the greatest effect from it. I messed this on up right here. Oh no, I didn't. I'm an idiot. All right. Here we go. Come on. That would have broke the whole thing. Okay. There's our circuit, baby. Yes. Come on. Keep pushing. Why are these connected right here? These should not be connected. What? When did that even happen? Let's go. Let's go. Let's go. Let's go. All right. All right. All right. Come on. We have a whole mess of situation going on here. What happened? Good lord. Okay, that comes out of 5 volts into the big cap, into the small cap, no cap. All right, great. Then data comes out of 6. Should not be going into ground at all. How did this happen? We almost lost it there. All right, let's do quick manual inspection before we have the ERC check. Okay, so ground is going to this undoing stuff, or am I losing my mind? Oh, this is 5 volts also, not ground. 5 volts is going to this capacitor, and then this needs to hit here. Why are you not doing that? Oh, it just did that. Okay. That's strange. Alright, 5 volts comes in, big cap, goes into VSS or VCC, whatever. VSS, great, okay. The other leg of 5 volts should not be going there. Ah, okay, this is what we did. Okay. There we go, that's better. No. Please stop, Max. You're an absolute menace. Okay, 5 volts. The only thing that 5 volts should be going to is the cap and then to VSS. Yes, great. Okay. Ground is going to the ground pins. Beautiful, the ground pins. And then GPIO 6, which is pin 3. It's going to the resistor, and then to data in and data out, all the way through. Yes, okay. 7 is just going to the switch. That's it. Was a pleasure watching, Max. Good luck with the product. Need to leave. Have a wonderful day. Yes, thank you, brother. You have a great day, and Happy New Year's. All right. We are looking good here. Let's check this. I know it's going to give me an error about power source. Electrical rules checker. So we got to make all these happy because they're not happy right now. We got a power flag. And then we add a... How dare you? We actually add a power flag to this too. Oh, I'm so silly. Why is that one not happy about that? That one is not psyched. Okay, input power not driven by any output power pins. Yes, you are. Okay, why? Is not a fan of my setup here. Doesn't like it. This cap giving us problems? Ah, the cap is giving us problems. No cap. Did I not see that this has polarity? Hi, Max in community, or better said, community. Yes. Good morning, Miguel. How are you today, my friend? Happy New Year's. What's your New Year's resolution? What are you doing this coming year? What are you building? What are you working on? I gotta know. Give me the deets. I don't want that cap. I don't want that. The capacitor, I do not want that one. We're gonna use something else. Let me log into my AliExpress account and see what I've ordered. It is a 1210. That is what it is. This work. Why are you doing this to me? working everywhere, but not this one. Where are we now buffering? I am trying to figure out a bug here where I cannot get electronic rules checker to pass on my schematic. Right now I have my schematic drawn up. I have the button right here, and then I have my resistors for my data line. I have my capacitor for my LEDs. And I cannot get, for some reason when I add this capacitor, it does not want to pass electronic rules checking. Could that be it? I'm an electronic engineer and I miss hardware part in my day-to-day. I have been working only with software programming. Yeah, that can be nice though, because some of this hardware stuff is really rough, super rough. I cannot figure out why it's so upset about having this capacitor here, but it does not care about the other capacitors at all. It makes me wonder if I'm like choosing the wrong cap, but I don't think I am.
Your desktop looks greener every day. Yes. Oh, I love to hear that.
Do you have any projects you're working on, like side projects right now? Switch on over to X. Come on over to the good side. Oops. I'm gonna sign into PCBWay and see if I can grab my schematic for a different PCB and see if I did something differently. I have 9 minutes to finish this. No, it doesn't have it. All right, my friends. This is gonna be GG's for now. I'll probably finish this just learning full stack and getting better at iOS programming, but it will be one of my New Year's resolutions to start some project. Yes, I love hearing that. That's awesome. That's amazing. I feel like the App Store is just like insane. Like I need to this coming year, I need to get into putting some apps out, and that would be really cool. But probably gonna be changing my tech stack then, which I hate doing. All right, so thank you guys for watching. We got really close to finishing the schematic. I don't know. This is a weird thing where I'm having an error on this pin when this cap is here, which I've never seen this before. I don't know why it's causing it. I'm sure it's something really stupid, but I'll come back to it later today and I'll figure it out, and then I'll post that the schematic has been completed. Thanks, guys. I'll see you in the next one.
Peace.